In this video, we will work on this problem from 2022 paper 1. So first step, you read the problem very carefully, identify the key points, what is happening in the problem, right? Identify the goal very clearly, what the question is asking, and then think about the key steps of the problem, and then you start solving it. So if you read the problem, it says there is a sphere, and this is very important because it is not a disk, right? So a sphere, not a disk, because how it will matter if you miss this and you assume it is a disk like a cylinder, then when you will write moment of inertia, that will be different and that will change your answer. Okay, so it says, and also other thing is solid, not hollow, solid sphere, right? That is rolling without slipping down a slope. So this is rolling without slipping down a slope. So as it is moving down the slope, it is rolling clockwise and it is moving downward. And it says no slipping, right? There is no slipping without slipping. That means at this point, there is no slip, right? Okay, so we can say the velocity of the disk at this point at any time is equal to the velocity of the slope, which is 0. Other thing, there are two parallel and opposite forces applied on the sphere, and they are 1 Newton. So this is 1 Newton and this is 1 Newton, and we are applying it at distance r from the center, one Newton upward, the other one downward, right? So it is like a torque couple, right? The question says the magnitude is 1 Newton, right? And r is given as 0.5 meter. So we have to find out, the problem is asking the acceleration of the sphere down the plane, and the unit is meter per second square. So the question is asking about this acceleration here, this value, that a, right, that meter per second square, question mark, how much is it? And it is saying for the gravity, please take 10 meter per second square. So the goal is to find acceleration. So when you look at this problem, you must realize, right, if you have done enough practice, you must know that you have to apply Newton's law, right, for translation. So for translation, it will be F equal to ma, Newton's law, and then you have to apply Newton's law for rotation. See here, rotation, right? It is rolling without slipping down the slope. So for rotation, it will be tau torque equal to moment of inertia alpha. And remember this moment of inertia, to get it right, you have to remember it is a solid sphere. If you by mistake you assume it is cylinder, you will write wrong moment of inertia, you will get the wrong answer and you will lose your points. And remember, there is no slipping. So these are the three things we have to do, right? So let us start with draw the forces on the sphere. As it rolls down the slope, think about the forces acting on the sphere. So these forces that you already see in the slide, they are quite obvious, right? You have weight acting downward at the center, right, of the sphere. You have normal force by the ground at this point, at the contact point, perpendicular to the surface. You have these 1 Newton, which are given in the problem, right? See, there's one force, and I will tell you that is friction, right? So there is a force, friction, and at this point here, right, friction. So this friction, now I draw it up the slope, but how do you know that it will be acting upward? Why not downward? Why not this? So how would you decide that? So let me explain this. So what we know, that the disc is rolling without slipping, and of course it's going downward, right? So here you have A, that is meter per second square. It is called linear acceleration. And then because it is also rolling, so you have alpha, like rotating, right? And that is called angular acceleration, and the unit is radian per second square, right? So for this sphere to roll clockwise, because if it is going downward, it will be rolling clockwise, right? So there has to be a total torque. There has to be total torque, right? The torque on the disc, sorry, sphere. See, I say disc. It is a sphere, not a disc, right? The total torque, this tau, right? This torque, the total must be clockwise. Now let us look at this figure. The mg, the weight, is acting at the center, so it is not creating any torque about the center of gravity. Normal force is not creating any torque. This 1 Newton and this 1 Newton, they are creating a counterclockwise torque. And we just concluded that if the disc is rolling without slipping downward, the net torque on the sphere has to be clockwise. So the friction has to be upward. Then it will create a net clockwise torque on the sphere. So that's how we know that this is correct. That friction is acting upward. This is wrong. So when you are giving the exam, you won't have that much time to think. I mean, here I am explaining, so I'm taking my time, but there you have to know these things quickly, and that will come from practice. So now, see, so this is the final figure. You have friction, this F again, I will write, this is friction, right? This is friction, okay? F, and that is acting upward. We talked about it, right? You have weight, you have 1 Newton, which is given in the problem, equal and opposite, and you have normal force. And because of these forces, you have A, meter per second square, linear acceleration downward, right? You have that downward, and you have alpha, which is angular acceleration clockwise. And this here is A. So the question that is asking, what is A? And this is your A in this fill in the blank. That's what the question is asking, right? So if you again remember that when we were briefing the problem, we have to apply 3 points: rolling without slipping, right? Rolling without slipping, and Newton's law for translation, F equal to ma, and Newton's law for rotation, tau equal to I alpha, right? So let us start with rolling without slipping. So if it is rolling without slipping, right? So at this point, we will know there is no slip. At this point, there is no slip. At this point, no slip. And because this slope here is not moving, it is ground at rest. So that means this point is the velocity is 0, right? So at this point the velocity is 0, right? So this point here, let's call it C. So C is instantaneous center of rotation. Instantaneous center of rotation. center of rotation. That you can imagine that the entire sphere is rotating about that point C at that moment, right? What would that mean? That C is instantaneous center of rotation. That means velocity at C is 0. Velocity at C is 0, right? And you must know these formulas in the exam. You won't have time to think about this, right? You must know it, right? So the formula for rolling without slipping is straightforward. That is A equal to R alpha. That is the formula. R is the distance between the center and point C, which is the radius of the sphere. A equal to R alpha, right? So that is your one equation from rolling without slipping. Now, second thing, we are going to apply Newton's law for translation down the slope, right? Down the slope, which means in this line, and let's say down the slope is positive, and what is this direction? This is theta degree, right? So let us write F equal to ma down the slope. So we are going to write F equal to ma, F equal to ma here. So let's go back here. I don't know what happened exactly. Yeah, okay, it's good now. So F equal to ma in this direction, right? So what are the forces that are acting in that direction? Normal force has no component, right? Normal force has no component. Friction is in the opposite direction, so you will have minus F, right? It is acting up the slope. This 1 Newton is acting down, so you will write plus 1, right? And this 1 Newton is acting up, so it will be minus 1. They would cancel out, as you can see. Then mg, the weight of the sphere, will have a component along the slope, right? And what would that be? So if this is theta, if you think about it, so here, if you draw this line, right, and you think about it, right, so this angle is theta, right? This is theta. So this angle here will be 90 minus theta. This is 90 degree, so this will be theta, right? So the component of weight along the slope will be plus mg sine theta, plus mg sine theta, and that will be equal to m, mass of the sphere, a, right? So if you simplify it, we will get minus f plus mg sine theta equal to m a, right? And again, remember what we have to find out. We have to find out a. So that is the second equation we got, right? Now, the last concept, let's apply the Newton's law for rotation, right? About the center of gravity, about G. So we are going to write tau equal to I alpha. I is moment of inertia, remember, right? About G, about the center of gravity, and we are going to say clockwise is positive. So you will see normal force will not create any torque because that force is passing through the center of gravity, G, right? mg will not create any torque. Friction will create a torque, a clockwise torque, and that will be F right here. That is F, right? That is creating a clockwise torque, and that will be F multiplied by R, right? That is clockwise, so that will be plus. And then this 1 Newton here, this 1 Newton will create a counterclockwise, and this distance is R. If you look at it, this is R, and same thing here, this is R, right? So what will happen? You will have minus 1R, right? Minus 1R, and this minus 1R, and this 1 Newton will also create a counterclockwise, right? So that will also be minus 1R and equal to I alpha, right? So you will have basically FR, and you will have minus 2R equal to I alpha, okay? And that is your third equation. Okay, so now what we're going to do, we are going to take the three questions and we are going to simplify, solve for A. We're going to plug all the numbers and we will get our answer. So what I'm going to do, I am going to copy this slide, right? And then I'm going to write down the three questions and then we will solve for A. So we have the three questions now, right? And we have to solve for A. Now let's plug the values, right? So some values are pretty straightforward. So from here you can have A equal to, because the R is 1 meter, right? Radius 1 meter. So the actually the calculation is going to be very straightforward. So A equal to alpha, right? And then from here minus F is the friction, plus M. What is M? Here mass 1 kilogram, so M is 1 kg, right? M is 1 kg, so M is 1 and G is 10, so 1 into 10, that will be 10, right? 10 and sine of what is theta? 30, so sine of 30 degree, right? And equal to M is 1 kilogram, so 1A, right? So if you simplify it, we will have minus F plus sine 30 is 0.5, right? So that will be 5 equal to A. So see, simplified, right? A equal to alpha, right? And then from here you have F. What is R? R is 1 meter, right? And then what is lowercase r? This lowercase r is 0.5, so 2r will be 1, so F minus 1 equal to, now we're going to write I, right? So I will write here I for a sphere, and that's where you have to remember it is a solid sphere, right? So I will be 2 by 5 mr square, and m is 1, right? M is 1 and radius is 1 square, so it is 2 by 5, right? So you have 2 by 5, and what is r? R again is 1, so you have simplified. From here you will get F equal to 1 plus 2 by 5, right? So that will give you 7 by 5. Now I want to highlight something, right? 7 by 5 newtons, right? Now one big mistake will be that you do everything right so far, and by mistake you do this, that there is a normal force here N, and then you have a friction like this, and then you write F equal to mu N, and then you will mess it up. The reason is this friction is static friction, right? So static friction, so I will cross it. You can't say it is mu N, right? Remember, the static friction is within a range, so the static friction can be anywhere between 0 and the maximum value mu N. If it was kinetic, if there was slipping, then it has to be a fixed value, right? But if it is static, it will be between that range, right? So you will find out that it is 7 by 5 Newton, okay? And if you write mu N, then you will mess this problem up. Then you are doing it wrong, right? And from here, if you put 7 by 5 here, that will give you A actually, and it's pretty straightforward. So what I will do from this here, you can see now it has become very straightforward. You have A equal to minus F minus 7 by 5 plus 5, right? And you will get your answer. Okay, so again, the static friction is in a range. That is the most important thing, like one of the most important thing you cannot forget. And I also realized I made a typing mistake. Look at this third equation. Look at this equation. Go back. This is Fr minus 2r equal to I alpha, right? So we cannot afford these kind of mistakes in the test. So I will correct it here. This is actually I alpha. And I apologize for that, but you have to be very careful when you are in the test, right? So from here, I will correct it again. This is F minus 1 I alpha here, so that will be your alpha, right? Here alpha, right? So basically this is wrong, so I am going to correct it. It's still the static friction concept. You should remember, like that will be a big mistake if you write F equal to mu N. It can be anywhere between 0 and that maximum value. So anyways, I will correct my calculation. So F will be 1 plus 2 by 5. And remember, alpha equal to A, right? Alpha equal to A. So if alpha equal to A, so you will have F equal to 1 plus 2 by 5A, right? And now from here, what you can do, you can write minus 1 plus 2 by 5A, right? Plus 5 equal to A, and now this is a linear equation in A, and that will give us A. So if you solve it, you are going to get A equal to 20.7 meter per second square, and that's the answer we will write here. So I'm going to write here that is 20.7, and we have solved it. So I will quickly review this problem. When you are in the exam, remember you will have approximately 5 minutes to do this problem. You have to quickly highlight the important points. It is a solid sphere, right? You have to remember rolling without slipping, and when you look at this problem, you must realize right away that you have to apply Newton's law for translation, F equal to ma, and Newton's law for rotation, tau equal to I alpha. Right? After that, it is a game of algebra, just doing the math right. And important thing, please don't forget, it is not kinetic friction because there is no velocity at this point. So it is static friction, and in static friction, F is in a range from 0 to a maximum value. So do not put mu n, right? And if you do that, you will then make a mistake. And when you do that, when you do everything right, you will get 20 by 7 meter per second square.